In this video, I'm going to discuss a sample problem in addition to the first video that I had about this method, the virtual work method. The sample problem is about beam deflections. Okay, now let us have a review first of the virtual work equation. The first one is for deflection or displacement, no? Vertical or horizontal displacement. Okay, it's unit 1 refers to unit load and delta refers to the displacement. Is either horizontal or vertical displacement. So is equal to the integral of small m times m capital M over EI dx from 0 to L. So 1 is the external virtual load acting on the beam or frame in the direction of delta. So if you assume that the displacement is downward, then the load must be downward also. Small m is the internal virtual moment in a beam or frame. It expresses as a function of x and caused by the external virtual unit load. Delta is the external displacement of the point caused by the real loads acting on the beam or frame. So, if horizontal displacement ang unknown, ang virtual load na to must be horizontal also. Pag vertical displacement ang i-determine, vertical unit load sa datong i-apply. Okay. Capital M is the internal moment in the beam or frame expressed as a function of x and caused by the real loads. E, modulus of elasticity of a member, and I is the moment of inertia of cross-sectional area computed about the neutral axis, or we call it the centroidal moment of inertia. For the other displacement, or this one, this is for rotation. Delta is displacement or translation. This could be horizontal displacement, vertical displacement, or rotational displacement, rotation, slope. No? We can just replace this one by theta when we solve problems. The small m here with the subscript theta to indicate na the virtual load is a unit moment. The external virtual unit moment. Ang small m, it's an expression in terms of x. Okay, so for this problem, we're going to use this formula in determining vertical displacement, or we call it deflection, and the rotational displacement or the slope. Okay, here's the problem. For the simple supported beam ABCD, determine the deflection at B and the slope at point C. Assume EI is constant. So, first thing you need to do is solve for the reactions. So, assume that the reaction at A is upward and also the reaction at T is also upward. So, you can sum up moment either at A or D to solve for one of the reactions. Okay, let us sum up moment about point A. And our sign convention is counterclockwise moment positive. So about point A, the moment of 200 is negative since clockwise. Sa 400, negative also since clockwise. But for RD, it's positive kay counterclockwise man. So it's simply force times distance, force times perpendicular distance. And we have RD equal to 425 pounds. So this is 425. To solve for RA, you can sum up force about the vertical. Sign convention, upward force positive. And we have RA equal to 175. Also upward. By the way, this is just an assumption. The direction is an assumed one. So, pag positive siya, it means na ang assumption ni mo is correct. So, therefore, upward ang duha ka reactions. So, first is we determine the deflection at B here. Deflection at B, and the other one is the slope at C. So, the first step is to determine the moment equations for each segment due to real loads or the capital M. Okay, so this is our original beam. So we have three segments, AB, BC, and CD. So sa virtual work method, it depends kung asa ang reference. No? Normally, pag first segment, the reference is always pinaka-left na point. But for the middle segment, it depends on you. Asa mo reference, B or A. No? Anyway, I'm going to show you two solutions. The first one is for BC, the reference is at B, while the alternate solution for segment BC, the reference is at A, and we'll compare if we have it will give the same answer. Okay, so analyzing segment AB, you cut a section somewhere in between AB, cut. We have this one. So the distance x is referred at A. So x ni. And using sign conventions, shear and moment diagrams, if you analyze the left side of the cutting section, the direction of moment is counterclockwise. But if you analyze the right side or the right side of the cutting section, the direction of moment is clockwise. So for this one, just equate counterclockwise movement equal to clockwise movement. So M is equal to 175x. This is for segment AB. Now for segment BC, this is our first solution. Let's refer X point B. So X is referred at point B. So cut a section somewhere in between B and C. Cut, and you have this one. Since X is referred at B, so dirigi ka itong X. Okay. And the distance from A to B is 3. And you add, M. So, sum up moment at the cutting section, counterclockwise moment equal to clockwise moment. And we have this one. MBC equal to 175, 3 plus x minus 200 times x. You simplify, expand this one, and you will get this expression, 525 minus 25x. Now, for the last segment, the usual reference is the rightmost point, or for this one, it's point D. Para simple. You can also refer A sa C if ever you want to analyze the right side sa cutting section. Left side of the cutting section. But it's more complicated compared to the right side. So cut a section somewhere in between C and D. and you analyze the right part, it's very simple. So x is referred at d, so na-delete ang x. And again, if you analyze the right side, the direction of M is clockwise. So equate again, counterclockwise moment equal to clockwise moment. So MCD equal to 425. This is for capital M. Next step is determine the moment equation for each segment due to a vertical unit load at B. Okay. Now, from the original beam, it seems obvious na the vertical displacement of B is downward due to this load. So, mo-deflect siya in this way, concave upward. So, na vertical displacement na downward. So, therefore, when we apply the virtual unit load at B, it's downward. 1.0. And you determine the reactions at A and D. So you sum up moment at A, you can solve for the reaction at D. Summation of moment at A is 1 times 3 equals RD times 8. So RD is 0.375 or simply 3 over 8. To solve for RA, you just sum up force sa vertical. RA plus this one minus 1 equal to 0. And therefore, RA equal to 0.625. So, kung unsa imong reference sa X sa step 1, same reference will be used sa step 2 for the virtual moment due to the moment expression due to this virtual load. So for segment AB, X is referred at A. This one, no? Cut, adhering X and small m, the reaction is 0.625. So the expression of M is 0.625 times X. For segment BC, X is referred at B. Okay, same lang. Ang na-change is the unit load and the reaction. So equate counterclockwise moment equal to clockwise moment. So this one and then subtract na 1 times X. And then you expand and then simplify and you get this one. And lastly, for segment CD, X referred at D, we have this one. Counterclockwise moment equal to clockwise moment. Okay. So you are now ready to determine the deflection at B. Okay, so to have a better analysis, it is suggested to construct this table para nakaka-guide, no? For segment AB, reference is at A. Sorry, typo error. For segment BC, the reference is at B. This is B, you know, B. And for CD, the reference is at D. So, this is the expression of M for segment AB. This one. Now, for AB, since X is referred at A, the limits of X will be from 0 to 3. And sa BC, since dire naka-refer ang X, 0 to 4. So you will not get confused. Ana lang. For segment BC with reference sa B, what's the distance of B from the reference B? Of course, 0. And what's the distance of C from the reference B? 4. Therefore, the limit is from 0 to 4. Okay. This one. B niya, sorry. Typo error, B. Okay. So, these are the expressions of M due to real loads. So, 175x, 525 minus 25x, and 425. This one. While for small m, this one, 0.625, 1.875 minus 0.375, and 0.375. Okay, review. This is the formula. So all you have to do is substitute the expressions of small m and capital M with limits, and then you integrate segment by segment. Okay. Substituting expressions and limits, we have this one. 0.625x times 175x over EI dx from 0 to 3. So you can integrate this one manually, or you can use your calculator if it is capable of solving integrals. If not, then manual ang pag-integrate nimo. Okay. These are the values for each term. So i-add nimo. Okay. The answer is positive 3,225 over EI pounds feet cube. Since positive siya, downward, no? Because our assumed direction or our direction of the virtual load is downward. So pag positive, it means corrected downward. Or therefore, the vertical displacement of B is downward. Okay. Now, for the slope at C, remember na for the slope, ang mag-change lang is the small m. Because for slope, this one is due to a virtual unit movement. Unit movement. Whereas there, unit load. But capital M is unchanged. Same lang. So, these are the expressions derived sa deflection, not B. So, no changes. Okay, but for the virtual moment or unit moment at C, okay, you assume na counterclockwise. So, if positive ang sign sa answer, it means nga correct siya, counterclockwise. But if negative ang sign sa final answer, therefore the rotation is clockwise. Kaya ang gi-assume nito diri counter. Okay. So again, we solve for the reaction. So when we sum up moment at A, 1 is counter. Therefore, clockwise ang moment sa reaction sa D. So kung clockwise, downward. And the value is 1, moment naman 1 divided by 8. So 1 over 8 or 0.125. And when you sum up force sa vertical, i-balance siya. Downward, nata upward. 0.125. So, since we are using the expressions of capital M with the respective references, we use the same reference for small m. Like for EB, reference is at A, for BC, B, and for CD, it's point D. Okay. So, same lang X, but different reaction. Therefore, ang expression na to is 0.125x. Sa B, okay, since wala tayo load dire, only the reaction. So, pag moment, same lang. 0.125, but the distance is 3 plus x. So, you expand, you have this one. And then for CD, referred at X, referred at D, again, Minus, no? Kaya puro clockwise ang moment. MCD is negative 0.125x. Again, B. B is a B. Refer that B. Same expressions for capital M. So, ang ma-change lang is small m. Okay, 0.125, 0.375 plus 0.125 negative 0.125. This one, 1, 2, 3. And using this formula, okay, we can just replace this one by theta to indicate na slope. Okay. So, solve manually or using your calculator. The answers are value for each term. Okay. Since positive siya, it means na counterclockwise. Counterclockwise. Okay, so that's it. This is the answers for deflection at B and slope at C. And for the alternate solution, it's for the middle segment BC. Okay. Because others want to use the leftmost point as reference. Okay, let's see if we will have the same answer. So first, deflection at B. Okay. For segment A, B, no changes since X is referred at A. No changes. Same expression sa previous na solution. Sa BC lang. X is referred at A. So, for this solution, X is referred sa pinaka-extreme na point, left or right. So, BC, X referred at A. So, nadargikan ang X. And since 3 niya, this is X minus 3. And M, okay, sum up moment, we have this one. 175x minus 200 times x minus 3. Simplify this one. And for CD, no changes since the reference is point D. Same lang. Now, for the virtual load, for AB, same lang. Sa BC, since X is already referred at A, mauna niya ang distance. So just equate counterclockwise movement and clockwise movement. So expand this one. And then for CD, same lang. So sa table, again, another, not edited. This is A. The reference is A for segment BC. Now, you will notice the limits is from 3 to 7. Okay. So that you will not get confused. The reference is A and we have segment BC. So, ang pagkuha sa limits is, what's the distance of B from the reference A? Of course, 3. Therefore, our lower limit is 3. The distance of B from A is 3. What's the distance of C from A? Of course, 7. Distance of C from A is 7. So our upper limit is 7. 3 to 7. Okay. So substitute expressions. The answer is the same. Although lahi ang expression, lahi ang limits, pero ang answer niya is the same. And same value for deflection. 3225 over AI. Same sa first solution. And for the slope at C, no changes sa moment expression, moment equation due to real loads, no changes. Okay, for this one, sa AB, no changes. Sa BC lang. Since the reference is at A na. So, moment is just equal to 0.125 times X. It's very simple na. For CD, no changes. Okay. Again, this is A. For segment BC, it's the reference is point A. So, substitute expressions and the final answer is same lang. It's 1,350 over EI. So, dili mag-matter kung asa ang reference for middle na segment ha. Okay. What is important is ang correction din mo limits. Although lahi ang expression sa middle term, lahi sa ng limits, pero ang answer na same lang. Same also with the last segment. If you want to analyze the left side of the cutting section, pwede ra. Like for example, CD. And then you want to analyze the left side. CD, CD. If your reference is C, of course, 0 to 1 limits. Pero if your reference is A, then your limit is 7 to 8. CD man ta, CD. And your reference is A. So what's the distance of C from A7? What's the distance of D from A8? So if that's the case, then 7 to 8 sa dato limits. Dili na. 0 to 1 ba? 7 to 8. Segment CD, but the reference is A, 7 to 8. Okay, so that's it. I hope that you have learned something from this presentation. Thank you for watching.